Welcome back to this channel. We are going to start a new chapter again, hydroxy compound in this video. So as usual, first we have to focus on the nomenclature. We draw the structure and then classify the alcohol. For sure, we also need to name the alcohol as well. Then next, in this topic, we are going to discuss the physical properties of alcohol, like what we discussed in chapter alkane. So first, we will focus on the boiling point and then the solubility in water. Okay, alcohol compound contain at least one hydroxyl group as the functional group, and its general formula is CnH2n plus 1 OH. There are two types of alcohol, aliphatic and also aromatic alcohol. Okay, so this one we will discuss further later, but what we want to emphasize in this topic now here is the new term that you have to understand. Basically, the carbon bonded to OH, if we want to simplify, give a name to this carbon, we will know it as alpha carbon. Okay, and then as usual, there are also three classes of alcohol: primary, secondary, and tertiary alcohol. Classification of alcohol also important because different class of alcohol will show different product when oxidation is happen. So let's start with the naming part. When we want to do a naming, we have to identify the functional group. So for example, in this compound here, we have the benzene ring and we also have the hydroxyl group. So when we have more than one functional group, means that you have to refer to the list of the priority. So in this case, hydroxy will be as the parent because the priority, it is at the higher position in the priority list. Okay, so therefore this will be first carbon, second carbon, third carbon, and fourth carbon. So carbon 2 consists of hydroxyl group. So basically we can name this one as 2-butanol. Then this is the substitute. When the benzene ring as the substitute, it will known as phenyl. So the correct name will be appear in the next slide. Yes, the correct name is 3-phenyl-2-butanol. Another example of the alcohol compound which also consists of two functional groups. One is carbon-carbon double bond and another one is the hydroxyl group. So again, when you focus on the priority list, hydroxyl has the higher position, so it will become the parent name. So this one will consider first carbon and then we will clockwise so that the position of the carbon-carbon double bond also as lower as possible. So and then we have 3-methyl, 4-5, so this is methyl, and then 5-isopropyl. So when we have two substitutes here, then we have to consider the alphabetical order. So just based on the parent, the name of this compound is 2-cyclopentene 1-O. Yes, when considering the alphabetical order, the I comes first, followed by M. So that's why the name is 5-isopropyl, 3-methyl, 2-cyclopentene 1-O. Okay, if possible, please make it in one word only. 5-isopropyl, 3-methyl, 2-cyclopentane 1-O. If the hydroxyl group attached directly to the benzene ring, this one will known as phenol, and the carbon will label as carbon 1. So if this is carbon 1, so when clockwise, the substitute will have smaller number, so 3-ethyl phenol. So if it is opposite side, so we know it is 1,4, so 4-bromo phenol. And if next to each other, 1,2, 2-amino phenol. Tutorial question B. Draw the structure and then classify the compound. Question number 1. 3-ethyl 6-chloro 3-decanol. As usual, we focus on the parent. So when mentioned about decanol means that this alcohol consists of 10 carbon, 4, 5, 6, 7, 8, 9, and 10. The third carbon consists of OH group and also the ethyl. And then the sixth carbon consists of 4, 5, and 6 carbon consists of 4, 5, 6 consists of chlorine, and then complete with the hydrogen CH3, CH2, 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 CH, CH2, 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 CH3. So this alcohol is tertiary alcohol, followed by the second one, cyclopropanediol. Since we want the cis, so we have to draw the cyclopropan first. First and second carbon consists of hydroxyl group, and since it is cis, so the hydroxyl group have to next to each other. So this is the secondary alcohol. Number 3, we have 2-heptanol. Parent is heptanol, 7 carbon. 1, 2, 3, 4, 5, 6, and 7. Second carbon consists of hydroxyl group. Fourth carbon consists of bromine and also the methyl group. And then the last carbon consists of benzene ring as the substituent. Complete with the hydrogen CH3, CH, CH2, 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 and this one also CH2. And this alcohol is secondary alcohol. So last one, number 4, trans 2-pentane 1-O. So means that the carbon at the first carbon attached with the OH, and the 2 is the position of the double bond. So first carbon, second carbon, double bond. Okay, and then we will consist of another 2 carbon. So first carbon consists of hydroxyl group. So this one will be hydrogen and this one will be hydrogen. Okay, so I think from here we roughly get the idea. So we can withdraw the structure in the transposition. So we take the transposition, have the hydrogen. Okay, then this hydrogen and this already write down. So we have another one part is the CH2OH, and then here is CH2CH3. So this is the trans, and this alcohol is primary alcohol. Okay, back to tutorial question number 1. A. Give the isotope name for the following compound. Okay, so we can see the functional group is over here. So basically, we already understand that we number from the right hand side. We'll be having the smaller number to the substituent. So 1, 2, 3, 4. So here CH2 have 3 times. So 5, 6, 7, and 8. Okay, so then here we also notice that there are 2 functional groups. One is halogen and then one is hydroxyl group. So as we still remember, hydroxyl group has the priority. So the parent name will consist of the OL. So this hydroxyl group is attached to the third carbon. So basically this one is 3-octanol. And then there is another substituent attached at the fourth carbon. So it's 4-chloro 3-octanol. Okay, so the second one, again, we will notice that the hydroxyl group is over here. So that's why we will give the lowest number to the hydroxyl. So this is the first carbon, second carbon, third carbon. And then definitely we will go up to become the longest carbon chain. 4, 5, 6. So from here we know that it is hexane. But then we have two hydroxyl group. Both hydroxyl group are considered attached to the first carbon. So we will going to has the parent name will known as 1,1 hexanediol. Okay, and then we have two substituent CH3, CH3. Okay, so uh, this one will be 3,3-dimethyl, and then we also have another substitute bromine is at the 6th carbon. So when we consider the alphabetical order, bromine and methyl, bromine come first. So that's why we're known as 6-bromo, 1,1-dimethyl. Sorry, not 1,1, 3,3-dimethyl. 1 hex 1,1 hexanediol. Okay, I rewrite again. 6-bromo, 3,3-dimethyl, 3,3-dimethyl, and then 1,1 hexanediol. Okay, so question number 3, we have 1, 2, 3, 4, 5, 6, and 7. Okay, sorry, we numbering near to the functional group first. This one is 3,3-dimethyl. So we have hydroxyl group, we have nitro, and then we have ethyl. So among these three, hydroxyl has the highest priority. So this one will be have carbon 1, and then definitely we know that we need to do the clockwise so that we have the lowest number to the substituent. So 3, 4, 5, 6, and 7. So this one is cycloheptanol, and then the hydroxyl group is considered as the first carbon. And then now we have two substituents. One is nitro, and then one is ethyl. But when we do the naming, we have to follow alphabetical order. So that's why ethyl comes first. So it's 3-ethyl, 2-nitro, 1-cycloheptanol. If you don't want to put the 1 also no problem, then it will become 2-nitro-cyclohexanol also. Okay, 2-nitro-cyclohexanol. Okay, carbon, the fourth structure is consists of carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Okay, so and then definitely we already have the idea. This is the lowest number, and then consists of 6 carbon, and then the hydroxyl group is at the second. At the third carbon, and the double bond is at the second carbon. So since then, the name will end with hexene because of consists of double bond, and then 3O, and then we need to put 2 in front to indicate the position of the double bond. So next one, we will continue with the question number 5. So definitely this is the first carbon, second carbon, third carbon, fourth carbon, and this is the fifth carbon. So then here we have one substituent. This substituent will known as benzyl. Okay, therefore the naming for the fifth compound over here is longest carbon chain of that consists of hydroxyl group is carbon 1, and then with 5 carbon, so will be known as pentanol. And then the third carbon consists of benzyl group, so will be 3-benzyl, 1-pentanol. Okay, now we are going to discuss the physical properties of alcohol. So first physical property that we discuss is the boiling point. So as usual, when we want to discuss about the boiling point, we have to relate with the intermolecular force. Okay, so when we draw the structure of the alcohol, basically we will notice that there are two possible intermolecular force that will be present, which are the hydrogen bond and van der Waals force. So let's look at the structure here. So if this is molecule A of the alcohol, and this is molecule B of the alcohol, so in between the hydrogen molecule, hydrogen atom and also the oxygen atom, there is possibility to form the hydrogen bond. Okay, and then if we have another structure over here, the R group will be possible to form the van der Waals force. So generally, due to the presence of the hydrogen bond, so generally alcohol will have higher boiling point compared to alkane, haloalkane, or even carbonyl compound. Okay, we will discuss carbonyl compound in the next two chapters. Okay, like just now we say, it's because of the hydrogen bond is relatively stronger than the van der Waals force. So for the alkane, haloalkane, and carbonyl, basically they only consist of van der Waals force. So similar with the condition of alkane, the boiling point of alcohol can be increasing with the number of hydroxyl group, because if more hydroxyl group means that it can form more hydrogen bond. So besides from that, it also depends on the molecular size. The bigger the size, the larger the contact surface area, so the stronger the van der Waals force and the higher the boiling point. So if you notice that there are same number of carbon, so we will look at the number of branches. Similar at the alkane, the more branches will have the lower boiling point due to the smaller contact surface area. Therefore, they will have weaker van der Waals force. Okay, so now we are going to arrange the boiling point as usual. So we have 1,2-hexanediol. So we have 2 hydroxyl group, hexanol, okay, N-butane, 1 propanol, 2,2-dimethyl-butanol, and propanol. Okay, so from here basically we know that N-butane going to have the lowest boiling point because only have van der Waals force, and the type of van der Waals force, if we want to specific, is London dispersion force. Just now we already mentioned that generally alcohol has higher boiling point than alkane, alkene, haloalkane, and also carbonyl compound. So propanol is one of the example of carbonyl compound. So that's why, however, the boiling point of propanol is higher than N-butane because the intermolecular force between the propanol, even though it's van der Waals force, but because of the propanol is carbonyl compound, which is a polar molecule, so they're going to have the dipole forces. Okay, N-butane non-polar, so London forces, London dispersion force, while the propanol is the polar molecule, so we'll have a stronger dipole forces. Okay, so after we settle with this, then we focus. Others consist of hydroxyl group, hydroxyl group. So in between these three, so we are going to check which one will have the lower boiling point. So definitely is the propanol, because propanol consists of 3 carbon, 2,2-dimethyl-butanol consists of 6 carbon, while hexanol consists of 6 carbon. 1,2-hexanediol also consists of 6 carbon. So all these are alcohol. So basically, the 1-propanol, 2,2-dimethyl-butanol, and hexanol, they only consist of 1 hydroxyl group. So we will compare in between these 3 first. So 1-propanol, 2,2-dimethyl-butanol, hexanol, and 1,2-hexanediol can form stronger hydrogen bond. Okay,
But then the 2,2-dimethyl butanol, 6 carbon, hexanol also 6 carbon, has a larger size than 1-propanol. So we consider that even though they have one hydroxyl group, so the strength of the hydrogen bond generally is relatively strong. However, what makes them different, besides from the hydrogen bond, then we focus on the van der Waals force. So if you still remember, the larger the molecular size, the bigger the contact surface area, the stronger the van der Waals force. So that's why the 1-propanol has the third lower boiling point among these 6 compounds. Then the 2,2-dimethyl butanol consists of 6 carbon, and then hexanol also consists of 6 carbon. So this time we are focused on the contact surface area due to the branches of the 2,2,6-dimethyl butanol. So if they have more branches, so they will going to have a weaker van der Waals force. And then lastly, 1,2-hexanediol has the highest boiling point because it consists of 2 hydroxyl groups, while the hexanol only have 1 hydroxyl group, even though both of them have 6 carbon. So due to the 2 hydroxyl group, so 1,2-hexanediol can form more and stronger hydrogen bond. So 1,2-hexanediol has the highest boiling point. Okay, let's continue with tutorial question number 2. Arrange the following compound in descending order of boiling point and then explain your answer. So descending means highest boiling point to lowest. So generally when we look at cyclopentanol, 1,2-pentane-diol, 1-pentanol, 2,2-dimethyl, 1-propanol, all these are alcohol. All are alcohol, so definitely consists of hydrogen bond. Okay, so because of all of these 4 alcohol consists of hydrogen bond, therefore we are going to look at which one have more hydroxyl group. Okay, so it's very obvious that 1,2-pentane-diol, okay, so I label this one as the B, has the more hydroxyl group. So the B12-pentane-diol has higher boiling point. Then now cyclopentanol have 5 carbon, 1-pentanol also have 5 carbon, then 2,2-dimethyl 1-propanol also consists of 5 carbon. Generally they have a similar molecular size. So means that now we are going on the look for the molecular shape to determine the contact surface area. Okay, so definitely cyclopentanol, the first compound A, because it is a cyclic compound with a planar structure, then followed by the 1-pentanol, okay, which is the straight chain, and the lowest boiling point will be 2,2-dimethyl 1-propanol because has the more branches. Okay, so based on this, why 1,2-pentane-diol consists of higher boiling point than cyclopentanol because B has more hydroxyl group, so means that they have more hydrogen bond. Okay, then now we compare another pair which is between the cyclopentanol and also 1-pentanol. Okay, so cyclopentanol, which is the A, is planar. Okay, so if A is planar, so means that it have a larger contact surface area. Okay, therefore stronger van der Waals force. Okay, then we have C and D, so maybe you can mention that D has more branch. So smaller contact surface area, contact surface area, and then will cause a weaker van der Waals force. Proceed to question B. Compound that contain NH group also associate with hydrogen bond. So what is your expectation in between the NH group with the OH group? Which one will be stronger and which one is weaker? So the strength of the hydrogen bond basically depends on the electronegativity. Okay, so as we always mention, the most electronegative element is fluorine, followed by oxygen and nitrogen. So therefore, in this case, the NH group will have weaker strength compared to OH group due to nitrogen is less electronegative, or you can say oxygen is more electronegative, also no problem. So based on your answer in part B1, which of these structure are going to have higher boiling point? One propanol and one propanamine. So the structure for propanamine again consists of 3 carbon, and then the first carbon going to have the amino group. So this one is CH2, CH2, CH3. Okay, so one propanol, OH, CH2, CH2, CH3. So definitely, which one has the higher boiling point? Propanol has higher boiling point. Okay, after discuss the boiling point, so next physical properties that we are going to discuss is the solubility in water. So as we already know, alcohol can form hydrogen bond. So definitely, they also can form hydrogen bond with water. So if able to form hydrogen bond with water, basically the alcohol are soluble in water due to both of them are polar molecule. So when we do the explanation for the solubility in water, we may use the keyword hydrophobic area and hydrophilic area. Okay, so before we go in details, maybe you can take note the word phobic, maybe like consider from the word phobia. So means that you are afraid with the water. Okay, we have certain area which is afraid with the water, or we consider like not friendly towards water. Okay, so now let's look at the structure. So basically the alkyl group is the hydrophobic area, and then the hydroxyl group is the hydrophilic area. So the meaning of hydrophobic and hydrophilic are the opposite meaning. Okay, then at the same time now we want to show to you that how we can prove that alcohol can form hydrogen bond with water. So this is the part just now we say the hydrophilic area of the alcohol, and then this is the water molecule. So hydrogen bond is always we have a hydrogen can bonded to either FO or N. So in this case are the oxygen. So the dotted line here is represent the hydrogen bond, which is in between two molecules. So the solubility of alcohol is going to decrease with the molar mass. Okay, with increasing of molar mass, because it's due to the larger hydrophobic area. So that's when we look at the alkyl group. The larger the alkyl group, that's when the bigger the hydrophobic area, and it is less soluble in water. So if the solubility of alcohol consists of a same number of carbon, but they are increasing of the hydroxyl group. So the more hydroxyl group means that the hydrophilic area is larger, so it will be more soluble with water molecule. So if the alcohol have similar size but with different branching, so we will say that when the branching is increased, the contact surface area is going to decreasing, and then the solubility will be increased. So now let's look at one example. We have to arrange 1,2-propanediol, pentanol. So propanediol 3 carbon, 2 hydroxyl group, 5 carbon pentanol and 1 hydroxyl group, and butane 4 carbon, no hydroxyl group, 1 propanol, 3 carbon and 1 hydroxyl group, 2,2-dimethyl propanol, 5 carbon and 1 hydroxyl group. So in order of increasing solubility in water, so explain your answer. So that means it's from the lowest solubility to highest solubility. So that is very obvious. 1,2-propanediol will have the highest solubility due to of 2 hydroxyl group, and then others has 1 hydroxyl group. Then we're going to look at the hydrophobic area. So propanol has the smallest, less number of carbon. So means that the hydrophobic area is smaller. Okay, compared to 2,2-dimethyl propanol, which have 5 carbon, and then pentanol also have 5 carbon. So with these two, we are look at the branches. The more the branches, the smaller the contact surface area for the hydrophobic area. Therefore, 2,2-dimethyl propanol also quite soluble in water. More soluble in water if compared to pentanol, while the N-butane has no hydroxyl group, so it is not soluble in water. Okay, so now after we already arranged, so now we learn how to do the explanation. Again, you will see that the explanation is going explained in pair. So first pair will be N-butane and pentanol. So we are going to mention that N-butane nonpolar cannot form hydrogen bond, so that's why it is insoluble in water. Okay, while pentanol, 2,2-dimethyl propanol, 1 propanol and 1,2-propanediol, they can form hydrogen bond with water and soluble with water due to the hydroxyl group. Okay, then now we are comparing both pentanol and 2,2-dimethyl propanol are isomeric alcohol. Isomeric basically here it means they have same molecular formula but different structure. So pentanol less soluble because it is straight chain, so the hydrophobic area is larger, so make the solubility lower. Okay. Then next we are going to compare another pair, which is 2,2-dimethyl propanol, also 5 carbon, then 1 propanol 3 carbon. So basically it's very obvious this is because they have different size. So if they have bigger size, the hydrophobic area will be bigger and that will be less soluble. Okay, last pair is 1,2-propanediol have 2 hydroxyl group. 1 propanol also have hydroxyl group. The difference is one is 2 hydroxyl group, one is 1 hydroxyl group. So you have to mention that they have more hydroxyl group, so the hydrophobic area is larger and make it more soluble in water compared to 1 propanol. Okay, directly we continue with the tutorial question. Question number 3A. So 2 ethanol 2 carbon, 1 pentanol 5 carbon, and then 1 hexanol 6 carbon. So basically all these three have 1 hydroxyl group only. So decreasing order, so that's when we have to choose most soluble in water. definitely will be ethanol. Okay, and then followed by 1 pentanol and 1 hexanol. Okay, so basically when we look at here is due to of the difference of the number of carbon, so it's the molecular size. So basically we can use this definition, this explanation. The bigger the molecular size, the larger the hydrophobic area, therefore it will be less soluble in water. Okay, so another one, 6B, which we can see, 3B, which is hexane. For hexane have 6 carbon, okay, and then no hydroxyl group. Hexanol 6 carbon also, 1,2-ethane diol, 2 carbon and then 2 hydroxyl group. This one is 1 hydroxyl group. So among these three, 1,2-ethane diol, 1,2-ethane diol is the most soluble, followed by 1 hexanol, and then the least soluble is hexane. So if you want to do the explanation, so you will going to say that this structure has more hydroxyl group, so larger hydrophilic area. Okay, so more soluble in water. While for another pair, hexanol and also hexane, so you can mention that hexane is non-polar molecule.